In this update, I completed section 6.6, did 6 problems, and section 6.7, singular vector decomposition. I only did a total of 8 problems. There were many more, but at this point in the latter part of chapter 6 with applications, I'm effectively cutting bait on some of the things that are discussed because I just am. I did SVD and Anton, and some of the applications I'm not really that interested in. I'm more interested in the concepts themselves, the theorems, the core content. So I would likely make a whole video just to finish chapter 6 with a lot of reading and a few problems. But here goes SVD and a little bit from the previous section. No more videos from Huffman and Kuntz, although I have been reading Huffman and Kuntz in my commute a lot. Read section 6.6 April 1st, 6.7 April 7. Only a few theorems attempted, 14 problems total, 7 theorems. I'm up to 649 problems, 499 proofs. At this time in the latter part of a book, yes, it becomes a little bit of a death march. And that's just what comes with the territory of doing a long book, even though I love doing long books. So yeah, I finished off the section 6.6, which was on orthogonal projections and the spectral theorem. And I'll show my reading, and I'll show how, and I've noticed this trend in chapter 6, that there are a few problems that needed an example, and I've had to go to YouTube to find examples that basically explain to me. I mean, it's nice to see it with the numbers. I think the spectral theorem deserved an example, and I'll show it because I found one. That's it. And then I did a couple of problems. And then SVD, the problems were pretty good, the calculation problems. I liked them a lot. There were a few fine points in some of the proof problems that I got a little lost with, and they're going to be for later. I did do some reading on the pseudo inverse also from Wikipedia. Interesting concept. But again, it's something that I know it's out there, and I've seen how problems are done for it, but I kind of skipped along. That's just the thing that's going to be to finish off chapter 6. Okay, so then the reading for section 6.6, there wasn't that much that I needed to add, but I added a few more diagrams just because I wanted to get it, and I did. The basic diagram in the book is very well explained. Then a couple of proofs, and then an example of an approximation by trigonometric polynomials. This is something that in engineering school you do like almost in day one. I remember doing this in 1986. So I did not go through it because I am familiar with it, but I'm glad that this book has it. Some more proofs. Of the reading, not for the actual problems. I only got one true and false wrong. That's good. I like that. I didn't get this right. Then I went back and I figured out exactly what they were talking about. But then I found a beautiful, beautiful YouTube example of how spectral decomposition happens and how you do all your projections. And then the matrix is equal to each eigenvalue by its specific orthogonal projection. That's all that the spectral theorem is saying. So I like that. Then I attempted a few more proofs. Some that I felt that I got. Oh, I'm sorry. This is section 6.7 reading. What am I talking about? Then I started reading section 6.7 for SVD. In one case, I calculated it and I got a different result than the book. And I was sure that I was correct. Let me see if I can find it in my notes. But yeah, I get different vectors from the book, and man, did I do it multiple times. Actually, this page is erased because I did it 2 or 3 times to make sure that I got the vectors. And the example flows the same way. It's just a factor that it comes in. But yeah, I kept saying I must be doing something wrong, but I don't think I am. So there may be an error in example 3 of section 6.7. I'm calling it that. I'm going to stick to that. More reading, and as always, I always work out the examples by outside of the book. So it's a very long read, section 6.7, all about the pseudo inverse after SVD. Then for the problems, I only got one true and false wrong. I felt very good about that. Then the calculation problems flowed smoothly, but then I got confused with one of them. Yeah. And anything using integrals, I got to go back and review at some point. I was close for some problems. After this, I realized the mistake that I kept making. I kept not doing these U vectors correctly, or not even attempting them. And then after that, I started getting them. And even though this problem does not have an answer in the book, the fact that I can get A from the matrices that I did tells me that I did it right. So I gave myself a check mark. Sure enough, problem 4, I got it right, 4A and 4B. So at this point, I was like, all right, I get how to do an SVD calculation. That's what I came here for. I'm going to try a couple of proofs. Not totally getting them, but I attempted them. And I'll just make a note here that there is a pickup at some point of SVD where I try to understand the problems that I did not attempt in FIS.